The Ford 300 Inline 6 powered millions of trucks for over 3 decades. Ford's Cleveland engine plant churned out these indestructible engines from 1965 to 1996, and the final versions produced 150 horsepower with 260 pound-feet of torque at just 2,000 RPM. But why did Ford use timing gears instead of a chain? How did owners routinely hit 300,000 miles without rebuilds? And which secret industrial version ran on natural gas for decades? These are 20 weird facts about Ford's Bulletproof 300 Inline 6 that will blow your mind. Number 20. The square engine design. Ford engineers gave the 300 an almost perfectly square bore and stroke, 4.00 inches by 3.98 inches. This wasn't random. Square engines balance torque production with reasonable RPM capability, and Ford knew their truck buyers needed low-end grunt more than high RPM power. The design philosophy paid off. While competitors chased horsepower numbers, the 300 delivered its peak torque at just 1,600 to 2,000 RPM throughout its entire production run. That's why these engines felt so strong in daily driving. Maximum twist arrived right where you needed it for towing, hauling, or crawling through mud. The square dimensions also contributed to the engine's legendary durability by reducing piston speed and cylinder wall wear compared to over-square designs. Number 19. The timing gear secret. Here's something that separated the 300 from nearly every other engine. It used timing gears instead of a chain or belt. Ford's engineers knew chains stretch and belts break, but properly engineered gears last essentially forever. The gear-driven valve train became one of the 300's signature features. No timing chain guides to wear out, no tensioners to fail, no rubber belts to snap and destroy the engine. Just metal gears meshing together year after year, mile after mile. Ford's factory literature actually bragged about these long-wearing timing gears, and for good reason. While other engines needed timing chain replacements at 100,000 miles, the 300 just kept running. Mechanics joke that the only way to kill the timing gears is to run the engine completely dry of oil, and even then, they might survive. Number 18. 7 main bearings. Most inline 6s made do with 4 main bearings supporting the crankshaft. Not the 300. Ford engineers specified 7 beefy main bearings, giving this engine bottom-end strength that rivaled V8's. Each bearing spread the load across the block, eliminating stress concentrations that caused failures in lesser engines. This overbuilt bottom end is why you'll find 300s with 500,000 miles still running strong. The 7 main design also contributed to the engine's signature smoothness. With a main bearing between every cylinder, crankshaft flex was virtually eliminated. Combine this with the timing gears and you had an engine that laughed at abuse. Fleet operators loved it because drivers couldn't kill it, and farmers appreciated that it would start every morning regardless of maintenance schedule. Number 17. The natural gas secret. While truck owners knew the 300 as a gasoline workhorse, Ford quietly sold industrial versions that ran on natural gas. Designated the CSG 649, these engines powered generators, pumps, and industrial equipment for decades. The natural gas versions used hardened valve seats and different pistons, but retained the bulletproof bottom end. What made the 300 perfect for stationary power? Its massive torque at low RPM meant generators could produce stable power without high-speed operation. Industrial users reported these engines running continuously for months at a time, stopping only for oil changes. Some CSG 649s logged over 50,000 hours. That's nearly 6 years of nonstop operation. Ford sold these industrial engines well into the 2000s, long after the pickup truck version ended production. Number 16. The propane conversion phenomenon. The 300's design made it incredibly popular for propane conversions. Off-the-shelf kits transformed these engines into dual-fuel powerhouses that could run on gasoline or propane at the flip of a switch. Why propane? For fleet operators, propane cost less than gasoline and burned cleaner, extending engine life even further. The 300's low compression ratio and conservative timing made it perfect for propane's different combustion characteristics. Propane-powered 300s became the engine of choice for airport tugs, forklifts, and delivery trucks. The conversions were so successful that some companies bought F-150s just to remove the engines for industrial use. Even today, you'll find propane conversion kits readily available because so many 300s still power equipment across North America. Nashville Fuel Systems still sells complete bolt-on kits that can be installed in a weekend. Number 15, the power rating mystery. Here's where things get confusing. The 300's power ratings dropped dramatically in 1973, but the engine didn't change. Early versions claimed 170 horsepower and 283 pound-feet of torque using gross ratings. Then 1973 arrived with new SAE net ratings, and suddenly the same engine made just 101 horsepower and 223 pound-feet. Did Ford neuter the engine? Nope. The difference was purely in measurement methods. Gross ratings tested engines without accessories, exhaust systems, or air cleaners, basically in ideal laboratory conditions. Net ratings measured power as installed in the vehicle with all accessories running. The engine itself remained virtually unchanged, but the numbers scared away buyers who didn't understand the rating change. Smart shoppers recognized the 300 still pulled just as hard as before. Number 14, the EFI revolution. Everything changed in 1987 when Ford bolted electronic fuel injection onto the 300. Suddenly, torque jumped from 227 pound-feet to an incredible 265 pound-feet at just 2,000 RPM. That's a bigger torque number than many V8s of the era. The EFI system wasn't just about power. It transformed the 300's drivability. Cold starts became instant, fuel economy improved, and the engine ran cleaner than ever. Ford's multi-point system injected fuel at each intake port, ensuring perfect mixture distribution. By 1988, Ford could claim the first fully fuel-injected pickup truck lineup in America. The EFI 300 became so torquey that Ford had to strengthen transmissions and drive shafts to handle the extra grunt. Owners discovered their economy six-cylinder could now outpull small block V8s in real-world driving. Number 13. The M50D manual marriage. Ford needed a transmission tough enough to handle the 300's massive torque, and they found it in the Mazda-built M50D 5-speed manual. This combination appeared in late 1980s F-150s and created a cult following. The M50D's deep first gear multiplied the 300's already impressive torque, creating stump-pulling power that embarrassed V8 trucks. Fifth gear was a true overdrive, dropping highway RPM for better fuel economy. The combination was so good that many owners still seek out M50D-equipped trucks today. The transmission's only weak point was the hydraulic clutch system, which could fail if neglected. But keep the fluid fresh and the M50D would outlast the truck. Some owners report the original clutch lasting over 200,000 miles thanks to the 300's smooth power delivery. The gear ratios were perfectly matched to the engine's power band. Number 12. The V8 killer reputation. Here's what frustrated V8 owners. The EFI 300 often matched or beat small block V8s in real-world performance. How? Peak horsepower tells only part of the story. The 300 made its torque from idle to 3,000 RPM, right where trucks operate. Contemporary 302 V8s made more peak power but needed higher RPM to access it. In stoplight-to-stoplight driving, towing, or climbing grades, the 300's massive low-end torque gave it the advantage. Ford's own towing guides showed the 300 matching V8 tow ratings. Insurance companies charged less for the six-cylinder, and fuel economy was significantly better. Many buyers ordered the 300 thinking they were sacrificing performance for economy, then discovered their economy engine could embarrass hot-rodded V8s in practical driving situations. The 300 proved that torque, not horsepower, moves trucks. Number 11. The forged crank mystery. Not all 300s were created equal. Heavy-duty versions, especially those bound for industrial use, received forged steel crankshafts instead of the standard cast-iron pieces. Ford never advertised this difference, but engine builders discovered it when tearing down high-mileage cores. The forged cranks were virtually indestructible, handling boost, nitrous, or extreme loads without breaking. How to identify one? The forged cranks have a narrow parting line and different casting numbers. Some appeared in medium-duty trucks, others in industrial applications. Today, these forged crank 300s are highly prized for performance builds. While the cast cranks were plenty strong for stock applications, the forged pieces gave an extra safety margin that some builders exploit for 400-plus horsepower turbocharged builds. Finding one is like striking gold in the salvage yard. Number 10. The OBS truck connection. The 300 helped create the cult following for OBS, old body style, Ford trucks from 1980-1996. These trucks combined simple styling with mechanical durability, and the 300 was the perfect engine for buyers who valued reliability over flash. OBS trucks with the 300 became the working man's favorite. Contractors, farmers, and fleet operators bought them by the thousands. Why? They started every morning, required minimal maintenance, and refused to die. While fancy V8 trucks sat in repair shops, 300-powered OBS trucks kept earning money. The combination was so successful that clean examples now command premium prices. Collectors seek low-mileage 300 manual transmission combinations, recognizing these as the ultimate expression of Ford truck simplicity. The 300 gave OBS trucks their reputation for being unstoppable. Quick! Before the final revelation, hit subscribe for more videos and drop a comment telling us which fact blew your mind the most. Number 9. The parts support miracle. Despite ending production in 1996, parts availability for the 300 remains excellent. Why? Ford used this engine across F-Series trucks, E-Series vans, and industrial equipment for 31 years. Millions were built, creating a massive aftermarket. You can still buy everything from gaskets to complete rotating assemblies. Performance parts are plentiful too. Headers, camshafts, and intake manifolds designed specifically for the 300. Even better, many parts interchange across the engine's entire run. A timing cover from 1965 fits a 1996 engine. This part's commonality makes rebuilding affordable and straightforward. Compare that to orphan engines that become expensive paperweights when parts disappear. The 300's long production run and widespread use guarantee parts availability for decades to come. Number 8. The 300,000-mile club. The 300's reputation for longevity isn't folklore, it's documented fact. Owners routinely report 300,000, 400,000, even 500,000 miles without major repairs. How? The overbuilt design left huge safety margins. 7 main bearings spread the load. Timing gears eliminated a common failure point. Conservative power output meant the engine never worked hard. Low piston speeds reduced wear. The long stroke meant excellent cylinder wall lubrication. Ford's quality control was exceptional. These engines had tight tolerances and excellent metallurgy. Regular oil changes were often the only maintenance required. Fleet operators documented million-mile 300s still running in delivery trucks. The engine outlasted multiple transmissions, several truck bodies, and countless drivers. When Ford finally discontinued the 300, it wasn't because the engine had problems. Newer emissions regulations simply required a clean sheet design. Number 7. The industrial workhorse legacy. Beyond pickups, The 300 powered an incredible variety of industrial equipment: wood chippers, generators, water pumps, air compressors, welders. If it needed reliable power, manufacturers chose the 300. Yale and Hister forklifts used specially configured 300s that ran on propane. Airport ground support equipment relied on natural gas versions. Irrigation pumps in California's Central Valley ran 300s continuously during growing season. What made it perfect for industrial use? The massive torque at low RPM meant equipment could operate at efficient speeds. The simple design meant field repairs were possible. Parts availability was guaranteed. Some industrial 300s have logged over 100,000 hours. That's 11 years of continuous operation. Even today, you'll find 300s powering equipment at construction sites, farms, and factories. Number 6. The fuel injection advantage. When Ford introduced EFI in 1987, they didn't just slap on a throttle body and call it done. The 300 received true multi-point injection with individual injectors for each cylinder. This sophisticated system transformed the ancient engine design into a modern power plant. Cold starts that once required pumping the gas pedal became instant fires. Altitude changes that would confuse carburetors didn't phase the computer-controlled system. Fuel economy improved by 15–20% in real-world driving. Emissions dropped dramatically. The EFI system was so good that Ford used similar components on their V8s. Diagnostics were simple, with OBDI codes. The reliability proved exceptional. Many EFI 300s still run on original injectors and sensors after 200,000 miles. Ford got it right the first time. Number 5. The torque monster reality. Let's talk actual numbers. The final EFI 300s made 260 pound-feet at 2,000 RPM. For comparison, the contemporary 302 V8 made 270 pound-feet, but at 3,000 RPM. That 1,000 RPM difference meant everything in daily driving. The 300 was already pulling hard when V8s were still building power. But the real story was the torque curve. Dead flat from idle to 3,000 RPM. No peaks, no valleys, just a wall of twist whenever you press the pedal. This characteristic made the 300 perfect for towing. No need to downshift constantly or rev the engine hard, just put it in gear and go. The torque was so abundant that many owners never used first gear except when heavily loaded. Second gear starts were normal. The engine's pulling power became legendary among those who actually worked their trucks. Number 4. The timing gear sound. Every 300 owner knows the sound, a subtle gear whine that tells you the timing gears are doing their job. Unlike time and chain rattle that signals problems, the gear whine was normal and healthy. Some owners worried about the noise, taking trucks to mechanics who laughed and explained it was the sound of reliability. The gears meshed with incredible precision, requiring no adjustment or maintenance for the life of the engine. Ford used fiber composition gears on the camshaft to reduce noise, but they still created that characteristic whine. Performance builders often replaced the fiber gear with steel for ultimate durability, accepting more noise for absolute reliability. The timing gear setup was so robust that catastrophic failure was virtually unknown. Even neglected engines with sludged-up oil passages kept running because the gears needed no lubrication system to function. Number 3. The compression ratio advantage. The 300 ran just 8.8.1 compression throughout most of its life, and that was genius. Low compression meant the engine happily digested regular unleaded gas, saving owners money at every fill-up. It also meant incredible tolerance for poor fuel quality, carbon buildup, and neglected maintenance. The low compression contributed to the engine's longevity by reducing stress on pistons, rods, and bearings. Detonation was virtually impossible, even under heavy loads in hot weather. The trade-off in power was minimal because the long stroke and excellent combustion chamber design extracted maximum energy from each power stroke. Turbocharged 300s loved the low compression, allowing significant boost without engine modifications. The conservative compression ratio was another example of Ford prioritizing durability over paper specifications. Number 2. The million-mile stories. Documentation exists of multiple 300s exceeding 1 million miles in commercial service. UPS, FedEx, and regional delivery companies kept meticulous records showing these engines survive an incredible abuse. One documented case involved a 1988 F-250 used for oil field service in Texas. The truck operated 24/7 hauling equipment, idling for hours in extreme heat, and consuming questionable fuel from remote tanks. At 1.2 million miles, compression was still within factory specifications. The original timing gears showed minimal wear. Main bearings looked nearly new. The owner rebuilt it preventatively, but the mechanic said it could have gone another 500,000 miles. These weren't isolated cases. Fleet managers specifically requested 300-powered trucks because downtime killed profits. The engine's reputation spread through word of mouth from drivers who'd never experienced such reliability. Number 1. The engine that wouldn't die. Here's the ultimate 300 story that proves its bulletproof reputation. In 2003, a farmer in Nebraska discovered a 1976 F-250 that had been abandoned in a field for 15 years. Mice had eaten the wiring, rust had claimed the body, and the interior was destroyed. But when he poured fresh gas down the carburetor and connected a battery, the 300 fired immediately. Not after cranking, not after coaxing, immediately. The engine had sat through 15 Nebraska winters and summers, temperatures from 20 to 105 degrees, with old oil turning to sludge. It didn't care. The timing gears hadn't skipped a tooth. The 7 main bearings hadn't seized. It simply started and idled smoothly like it had been parked yesterday. The farmer drove it out of the field under its own power. He changed the oil, replaced the fuel filter, and used that truck for another 5 years on his farm. When Ford discontinued the 300 in 1996, they didn't retire an engine. They ended an era. No modern engine matches its combination of simplicity, durability, and brute mechanical honesty. In an age of complex computer-controlled power plants, the 300 stands as proof that good engineering never goes out of style.